Hi, I'm Christian Gianchato, and I'm here to explain and give you some ideas about Fano Plane. This figure you see is a model of Fano Plane. Later, I'm going to show you how this model was constructed. So let's proceed on the definition. Fano Plane in finite geometry. The Fano Plane was named after Gina Fano. It's the finite projective plane of order 2. It is the finite projective plane with the smallest possible number of points and lines, which consists of 7 points and 7 lines with 3 points in every line and 3 lines to every point. Axioms. Axiom 1. There exists at least one line. Axiom 2. Every line of the geometry has exactly 3 points on it. Axiom 3. Not all points of geometry are on the same line. Axiom 4. For each two distinct points, there exists exactly one line on both of them. Axiom 5. Each two lines have at least one point on both of them. So this is the 5 axioms on Fano Plane. For more understanding and to understand more about these axioms, we will try we will try to construct the model of the Fano plane. So using these 5 axioms, we will try to construct the model of Fano plane. So according to axiom 1, there exists at least one line. So we draw one line. In axiom 2, every line of geometry has exactly 3 points on it. So we draw a 3 point line, 3 point on the line. So we labeled them as point A, point B, and point C. Axiom 3, not all points of geometry are on the same line. So we add another point, put here. Then axiom 4, also we label it as D. In axiom 4, for each two distinct points, there exists exactly one line of both of them. So in every 2 points, there must be one line. So we draw one line. We must connect point A and point D, point B and point D, point C and point D. So first, point A and point D, then point B and point D, then point C and point D. So next, action 5. For each two lines have at least one point on both of them. So every two line must have one point. Means in one point, example, point A, there must be two lines passing through it. So for example, this point A, there is two line which is passing through point A, the same as point B, point C, and point D. since it is said to the definition that there must be 3 points on every line, so we must add another points labeled as point E, eh, point F, and point G. Then, in action 4, they said that two distinct points must be exact. There be exists exactly one line on both of them. So we see that point E and F has no line connected with them. So if we try to connect them, then then it would be look like this. But the said in Fano Plane must be connected. All points must be connected to each other. So the best way to connect to each other is by connecting them to point C. Same as point G and point F. Then we must connect it to point A. Then after that, if you look closely, there's still points that are not connected to each other. Point E and point B and point G, then point G and point E. So what we will do is to make a line to connect them to each other by this. So as you see, the Fano plane was complete. Then all we're gonna do is check if this Fano plane has some has 7 points and 7 lines with 3 points on every line and 3 lines through every point that said in the definition. So let me use some presentable figure. First, I label them. This is point A, point B, point C, point D, point E, point F, and point G. We also label the line. We label this point line as line A, line B, line C, line D, line E, line F, and line G. So we check if there is 7 points and 7 lines. So first, the points count 1, 2, 3, 4, 5, 6, 7. So we got 7 points in this plane. Then we count the lines 1, 2, 3, 4, 5, 6, and 7. So we got the 7 lines correct. Then next, we check if there is 3 points on every line. So we check line A, which is consists of point A, point B, and point C. Then line B. Line B consists of point C, point G, and point D. The next line C. which is consists of point A, point E, and point D. Point, then line D, which is consists of point A, point F, and point G. Then line E, which is consists of line E, point C, point F, and point E. Then line F, which is consists of point B, point F, and point D. Then last, line G, which consists of point B, point G, and point E. So all the lines consist of 3 points. Every line consists of three points. Then you check the three lines through every point, which means every point must have three lines passing through it. So we check point A, see that point line A, line D, and line C are passing through point A. Line- Then next is point B. Point B, line A is passing line F and this line G. Next is point C. Point C consists of passing through line A, line E, and line B. Point D, lines that passing through point D are line F, line C, and line B. Next, point E, line C, line E, and this line G. Point F, point F is line F, line D, and line E. Last, point G. Point G, line B, line G, and line D. So we got all this correct with the Fano plane with 7 points, 7 lines, with 3 points on every line and three lines through every point. That's all. Thank you.